Alright, so I wanted to make a video on R8, kind of just explaining what it is and how it works and that sort of stuff. So this here is R8, obviously. It's a Fanuc robot, S420IW, that's the model. It has an old RJ2 controller on it, and we got this probably like 3 years ago. And the robot itself was made back in 1997, so it's quite an old robot right now. And that's actually why it was so easy to get. Once these robots are even just like 5-10 years old, they start to get replaced by the newer ones, the newer fancier ones. So Fanuc actually, I don't even think they make parts for this robot anymore. You can't get replacement parts for the controllers or replacement teach pendants or anything. So we were able to get this one really cheap at an industrial surplus store. We got it for under $1,000, and it came with the robot, the controllers down there on the back of it, teach pendant, and it came with an operator box too. And surprisingly, it pretty much worked. Just like right when we powered it up, we needed to replace a fuse and then clean up some fans down there in the controller, but that was pretty much it. It was a bit tricky getting it home. The robot weighs like 1,400 kilograms, which is like 3,100 pounds, which is heavier than some cars. So we ended up using a car trailer to bring it home. We had it on that, pulled it up, rolled it off, and we got it hooked up and everything. So kind of go over just like how it works, what stuff it has, and what everything does. So almost all industrial robots, and I mean almost all industrial machinery, needs 3-phase power to run. And since this is residential, we only have single phase here. We just have single phase 220, and this robot requires 3-phase, like 580. It's like 480 to 580. It's a really wide range. But so I have a 3-phase rotary converter, which are pretty common. You can make them yourself out of old motors, or I mean you can buy them too, but they're cheap. They're really easy to make. I have one that runs everything here. I have the CNC machine, the lathe, there's the saw in the other room, but all of that is powered from this here. There's an emergency, well, sort of like a lockout key to make sure it can't accidentally be turned on. Then the button that starts it and it lights up while it's running. So we have the power, comes in through that yellow cord down there, runs across, and runs into this. This here is called the operator panel. And this is basically just like the generic, most commonly used switches, buttons, lights, indicators, things like that. So we have an emergency stop, that goes back to the robot, and in an emergency that will stop the robot instantly, near instantly. We have the main disconnect. You use this when you want to shut off and isolate power to the robot. If you're going to change on anything, fix anything, or if you're going to work around the robot, you should always shut it off. And then there's a little lockout thing in there to put your lock in to make sure no one else can come and turn it on. We have the hour meter. That's how many hours it had when we got it, which is a lot. So this robot's been through quite a lot. It works surprisingly well still. I think we only put like 200 hours on it so far over the 2.5 years we've had it. So that has been a lot of work it's done. Standard just on-off buttons. These are what turn the robot on and off. Some alarms, fault reset, cycle start, things like that. Just generic use. This here is the connector for the teach pendant. We'll look at that later. And behind here is more of like a programming port for transferring programs and stuff. So that there, operator panel, operator box, goes over to this. I believe it's, I don't know, one of those cables goes back to the operator box, operator panel, whatever the heck it's called. And that there is the controller. That has a computer in it, I mean like an old computer in it, and the servo amplifier. Now that there basically is just what runs the robot. It handles all the motor controls, sends power to everything, gets feedback, does all the motion planning, all that sort of stuff is handled in that box there. None of that happens back in the operator panel. Alright, so this is a 6-axis robot, which is pretty much one of the most common types of robots to find in any industrial setting. That means whenever you connect to the end of it, the robot can move X, Y, and Z, which is just like a standard CNC machine. And then it can also move each angle about that axis. So basically anywhere that you can move something just with your hand, I mean any angle, any position, the robot can copy that and do the same thing, which is very useful for more like delicate work or spot welding sort of stuff where it has to get in around a part to weld it. So it being 6-axis means it has 6 motors. It has one there, which would be J1, that pivots the whole robot around. It has one on each side, there's one there, and one back on the other side. Those move these big joints right here. This entire thing pivots around that point down there, and then this joint here is controlled by the other motor, I believe. And it does that. There's a big counterweight down here, and this counterweight links up into the gearing of the other motor. And then there's a bar back here that pivots down in the counterweight, pivots up here. So as the counterweight moves up and down, it's linked to that arm, and that arm will pivot. 4th axis is this. This pivots the entire arm, it rotates around. J5 is this here, pivots all the way up and back down. The motor for that's actually inside the wrist here, and it goes in through some gearing and then links up to that. And finally, the 6th axis is right here. So there's a much smaller motor compared to those ones because it doesn't need to move nearly as much. So there's the motor, there's a small little gear reducer here, and then there's the faceplate. This here is just the little camera mount I made to hold a camera to record stuff. So it's got some bolts there, and you bolt on whatever you want, any tool. And to get like air lines and wiring or any controls to what you have mounted on the end, they have some ports down here at the bottom. There's an air line and then some like electrical connections, and those internally run up the arm and then come out right here. So you have your air, some electrical connections, a couple more connections, and you'd run those up over top of this whole thing with like some cable management and things like that. And then it would hook up to your end effector, which is whatever you put on the end of the robot is called the end effector, whether it's a clamp or welder or, well, anything. And then all of that can be controlled by either like external controls that you do yourself, or you can control it directly from the robot program. So take a look at the teach pendant. This here is what does all the interface between you and the robot. That's how you program it, it's how you change programs, change the speed, all of that is done through this. I saw a couple people in one of my other videos thought I was using a phone to control it, and I definitely wasn't, because that would just be incredibly unreliable. Everything in this entire system is like very well industrial and reliable, way more than just a normal phone would be. Everything's connected with wires, nothing's wireless. It all has safety, so if you unplug it while it's moving, it'll shut off. If it loses power while it's moving, it'll shut off. If anything goes wrong, it'll know before the robot just like goes out of control. That's something that will almost never happen. So this is how you program it. It has an e-stop here, which does the same thing as the one on the operator panel. When you press that, stops the robot instantly. This here is the enable switch for the teach pendant that basically turns on and off whether this is being used. And on the back, it has two what are called dead man switches. So what these do is these are just 2 position ones. The newer robots have 3 position, and you have to hold these ones. These ones just have to be held in for the robot to move. The newer ones have like 3 positions, so they need to be held in part way to work. But if you hold them in all the way, if you squeeze really hard, it'll trigger the e-stop and it won't run. And those are just for safety. So when you're programming this, normally these would be in big like cells with cages around them and all these safeties. And you're normally never near these things when they run because they're unsafe. I mean, a robot this big could easily injure you pretty bad if it's moving and it hits you. And the purpose of the dead man switches is so you can be in there with the robot when you're teaching it a position or trying to fix something, and it helps keep you safe. So in the event that the robot moves somewhere where it shouldn't be moving, or it surprises you or anything like that, you let go of those switches and it'll instantly stop the robot, and then you can like get out of the way or jog it backwards, whatever you need to do. I think that's most of the safety stuff. It has brakes on each motor. So obviously this is the motor. This back here is the encoder, which feeds the motor position and the position of the entire robot back to the controller so it knows exactly where it is. This section right here is the actual motor. That's what does all the actual moving. That's what does the power. And then this section up here is a brake. And it's spring loaded, so if there's no power applied to it, it locks up and doesn't allow the motor to turn. But the robot has to apply power to the brake to unlock it, and then the actual motor has to move the axis. And it has those in the event that, I mean, if you ever press the e-stop, those will enable and the motors will shut off. But also if there's ever a power loss and the robot's in the middle of doing something still moving and it doesn't have time to get back to a good position or anything like that, the motors will lose power and the brake will lose power too. But because it's spring loaded to be closed, whenever it loses power, it just locks the robot still and keeps it from dropping, basically. Because if you were to just pull this motor off and there was basically nothing connected to the gear, the axis would either flip forward because these springs here try to pull it inward and keep it balanced basically, or it would just fall down based on how much weight was on it. Also, I know a couple people have asked me if this was hydraulic at all, because these do look very similar to like big hydraulic cylinders, and they most definitely aren't. These are just springs and they try to pull inward, and they do that to help balance the weight on the robot. So J2 here has a lot of weight on it whenever it leans all the way back. And what these do is, as it leans back or leans forward, these get extended and try to pull the robot back up to center, which puts less load on J2. The robot is completely electric. It has no hydraulics, it has no pneumatics. I mean, no pneumatics that do anything. There's just a line there for whatever you want to connect to the end. It's all electric. And surprisingly, it doesn't take as much power as you'd think. On average, it only takes 2.5 kilowatts, which is, I guess, like just under 2 normal space heaters. Like just household space heaters, not like a big oven or anything. It draws on average less than most ovens or electric cooktops do. But at maximum power, if the robot's really trying to do something or lift something really heavy or move really fast, it'll draw substantially more. I think it goes all the way up to like 12 kilowatts or something it'll draw. And these are quite big motors for that. These are some of the largest servos I've ever worked with. They are 3.8 kilowatt, which is what, like 5 horsepower around, and that's continuous output. So there's one of those on pretty much every axis, which means this robot has an awful lot of torque and power, and it can move fast. These things aren't like, slow or anything like that. So payload. This robot is rated for, I believe, 165 kilograms. I'm not exactly sure. It's like 300 something pounds. And a lot of people ask why it's so low. Because the robot weighs 3,000 pounds. You'd think it'd be able to carry a little more than a tenth of what it weighs. And especially people that have worked with like hydraulic machinery, like excavators and things like that. Because hydraulic machinery can normally carry, or at least push, a lot more than it weighs. You know, they can pick themselves off the ground and things like that, but this robot cannot do that. And that is because this is built for precision and speed instead of just like high lifting power. So when this robot was new, it had an accuracy, like it could go around, move, come back, and the accuracy would be 0.4 millimeters. And I don't know what that is in inches, but it's not much. It's way more precise than any sort of hydraulic machinery would be. And it does that like every day. It'll do that constantly all day long. It's meant to be extremely repeatable, reliable, fast. It's not meant to be, you know, pick up the heaviest load and just sort of throw it somewhere. It's meant to be very reliable and precise, because you need that when you're welding stuff or moving big, heavy, expensive parts around to manufacture something. Alright, so I guess we'll get into actually running it. So to start it up, first off, we need to turn on the 3-phase. And just do that by enabling, and then start it up. You'll probably hear the transformers start up. Yep. So we now have the 3-phase on. We have to turn on the main power, and then we can start it up. Then you can hear the fan start up in the controller, and then the screen over here kind of goes through like a boot sequence. It takes a little while to start up. Alright, so there it is. And so first I'm just going to jog it around a little bit. And jogging is basically manually moving each axis. There's all the axis controls here. They're labeled J1 through 6. And you use those to manually slowly move around each axis, and you do that when you want to program it. So we have the teach pendant, we have the e-stop out, and you have to hold in one of the things on the back, hold shift, and then you can press any of these buttons to kind of jog that axis around. So we'll start with J1. You can hear a click, and that is the brakes pulling out, which disengages them. And then you might be able to hear sort of the high-pitched noise, and that's the sound that the motors make when they're enabled. So if we move J1, it just moves really slow. You can see it sort of going back and forth. And then use these little percent arrows down here to bring the joint speed all the way up to full speed, or you can see it a bit better. So there's J1, J2, 3, 4, then 5 and 6 are the wrist. And then when you let go of one of the switches in the back, you'll hear the motor shut off right away and the brakes engage back in, and then lock the robot there. So what I showed there was just moving each joint individually. The robot has a mode where, well, I mean, they all do. But so if you put it into jog frame, and then there's a bunch of other modes that do a very similar Cartesian based moves, which are what they're called, and that moves it so you're actually moving in the coordinate, like whenever you press X plus, it'll actually move X forward instead of just moving J1, which would just rotate the robot. So this actually allows you to directly move the robot in straight lines or pivot around different axes and stuff. So if I go to move it again, I'll start it out a bit slower and move X plus and focus and move X plus. So it enables, and now all the motors will move at the same time to make the end, which is, I believe, a point somewhere down wherever the lens of the camera would have been if I had one connected. So when I move X forward, the whole robot moves so that it moves in a straight line. And then it does that for each axis. And notice how when it moves, it doesn't move the rotation of what you have connected. So it stays in the exact same orientation to everything except the axis that you're trying to move. And then you can do rotations. Here. I'll change what point it revolves around. You can change what, like, basically what the center of is that it's trying to pivot around. So if I change it, this one here should be the center of, like, the faceplate. So now you can see it's around, basically, if you could imagine there being a point in the very center of the plate that the laser cut thing's bolted to, that's the point that it's moving around now. You can move any axis, any combination. And it does all the math, it calculates where the rest of the motors have to move to just move that axis that you want. So, to write programs, now, this robot is, I mean, as I said, it's really old, so the only way I have to write programs for this is manually teaching it. So I'm just going to make a new program here. It's pretty simple. Alright, so new program, just made one. It's just blank, named it Test 19, and there, as you can see, there's no lines in it. So the way you make programs on these older robots, the new ones you can hook up to a computer and you can simulate it all out, upload it to the robot. It's much cooler than how this one is. This one's very time consuming. But the way I program this is you jog it to a point, so I'll leave it in jog frame, and then move it somewhere. So we'll just make a point over here. So that's where the robot is, and then you just save that position, and you can choose whether you want to save it as a joint position or linear position. Joint positions mean all the motors start and stop at the same time, which is sort of the most efficient and easiest for the robot. It's easiest to just start them all and stop them all at the same time. But linear means it'll move in a straight line, which is like how I've been moving it just now. So wherever the point is that it starts, it'll move the shortest distance of the actual tool on the end. That tool will move the shortest distance to the next point. So I'll just do some linear moves because they're a bit easier to look at, but I'll do a linear move and then a joint move so you can see them switch between. So, alright, we'll make a linear move. We'll have it relatively slow. Then we'll move it back. So we'll have that be our second point. Hit point, save it as a linear move, and then we can run this program. So to run it, we have our two positions there. We have the speed, and then find means it'll go to that exact point, stop, and then continue on to the next line. They have find, and then they have continuous, 0 to 100. And continuous means, so if the robot's going and it has to make a sharp corner, if you have it set to find, it'll go to that exact corner, stop, and then continue going to the next position. But if you have it set to continuous, what it'll do is sort of round over that corner, and then the higher value you have set to continuous, the more it'll round it over to try to maintain speed as it goes around that corner. And doing that is mostly meant to speed up production times. So if the robot has to pick and place something, you don't need it to pick it up, straight up, stop, go across, stop, and then set it back down. You only need the precise, you only need the precision right at where it's picking up and setting down the part. When it's moving it, you can have it be faster and have it more curved. And that lets you basically have shorter cycle times, which means more money in a manufacturing plant. So we have our 2 positions. To run it, just hold one of the switches, shift, and then the forward button. The forward button runs it forward, backward button obviously runs it backward. Surprisingly, it took me a while to find these in the manual. There wasn't a very simple way to just run it that was listed. I had to dig through it. Alright, so we'll run that program forward. So we were at the end, so it'll jump back up to the beginning. Now that we're at the beginning of the program, we can hit run. Make sure you always have the speed set down. Anytime you're running a program, you want the jog speed, or well, just the program speed set to like 10% or lower when you first start. So we'll run that. And as you can see, it's moving very slowly. And since it's good, we'll put it up to 50%, which is a bit better to kind of just test the positioning. So there it is, it's done. It ran the program, just ran through both the steps that we have. If we want to run it faster, we can change these 100 millimeter a second to, let's say, 500 millimeter a second. And that is the actual linear speed of whatever point you have set on the end of the robot. So if we run that, and as always, test it to go a little slow at first. So there, much faster. And then say we switch those to joint moves. So instead of linear, we'll make them both joint. And you can just edit these in the program. You don't need to reset anything. So we'll test this again. And you might be able to see that it's not going in a straight line anymore. It's sort of arcing with the rotation of the robot. And actually I can change one of these to sort of go up a little bit, which would probably make it more pronounced. So if I save that as the second position, and then make them both linear again, and test that, as you see, straight line. But if I change them back to joint, and then run that, it's honestly a bit hard to tell, but what's happening is they all start and all stop at the same time, which means whenever the robot rotates around like J1, if it starts and stops at the same time and all the other motors do that, the point that we're trying to move is actually going to move in an arc around J1, and the rest of the axes will do the same thing. But in linear, it'll go in a perfectly straight line, and it'll just adjust all the motors to make sure it does that. And then basically there's all sorts of different ways you can program, well, all sorts of different things you can add into the programs. So obviously they have default positions, but they have different registers that you can store positions in. They have I/O outputs, which would be if you wanted to open and close like a gripper on the end of it, or a welder or anything like that. They have if statements, waits, you can have loops, you can call other programs up. So even though this robot is like 20 years old, there's still a lot of stuff that you can do just from the teach pendant, which is quite useful because just through the teach pendant, it's easy. You don't need an extra computer or anything like that. It is more time consuming. It would be a lot easier if you have a long program to do that in the computer, but the teach pendant makes it really easy to just do, simple programs. And so you save the program, you save a whole bunch of different programs, and I have a program saved for home position, which is called storage. So there's a storage program, really simple, just one position, goes there at 50% speed, it's a joint move. And if we run that, we'll run that at like 20%, that way it's not too quick. We'll run that, and then that position is the robot is the position that the robot just stays in pretty much all the time. It's most of the way out of the way. It's less likely to get damaged if it's outreaching somewhere, or for someone to walk into it, which honestly happens a lot more than you'd think. All the injuries that this robot has caused has just been people walking into it. Like those motors that stick out, that's the perfect spot for when you're down there working on some bolts or something for you to get up and hit into those. Same with when the robot's outreaching over something. Almost all the time, it just gets walked into. It's never once moved into someone or like pinched anything or broken anything. It's been very safe so far, but as always, you have to be safe with it. Always test everything at low speed first. If you don't need to have the speed up to 100, always have it as low as you can, just because that makes it safer. Pretty much all industrial robots are very similar to this. I mean, they have newer controllers, they look different. They're, faster, fancier, more efficient, all that, but they all still operate just about the same way. So if you understand how to use one of these, it'll carry through to pretty much all the newer ones and all the different robot brands. They're all very similar. So I guess that's all. I'll see you next time.